Cool, let's get started. By a show of hands, who read that document that was sent out about the new Kubernetes provider? Awesome. All right. So for those of you who haven't, I'm going to spend a little bit of time walking through the first half of that document, describing how for the next generation of the Kubernetes provider, we want to enable all of these manifest-based workflows. My name's Lars. I work on the Spinnaker team at Google. I've been on the Spinnaker team since a little before it was open sourced. I wrote a large part of the first iteration of the Kubernetes provider, and want to spend some time talking about how we want to make it better. All right, so first iteration was implemented what you can call the Spinnaker way. So at the time, the Amazon provider and the Google providers were in really good shape, and the implementation sort of followed their path, so to speak. But since then, since the implementation was first open sourced and very early 2015, we've seen the rest of the ecosystem sort of shift towards this manifest-based deployment. So basically, you have like a YAML file that describes a replica set or a deployment. You make a change to that, and then you apply that change to your cluster with kube control. So the Spinnaker way, it has a lot of advantages if you follow like the pure Spinnaker implementation path. So one, you get these advanced deployment strategies, is what we can call them. Is you have Canary, it's very powerful. Rolling red black, which isn't fully open source yet. You can even describe your own deployment strategies. And these are possible because of the assumptions that Spinnaker makes about how it's interacting with your cloud provider. You get to group your resources in meaningful ways. Right now, it's based on naming convention, but just when you first open up Spinnaker, you can already see that things are grouped into applications. You have various versions of your replica sets grouped into clusters, and all of this shows up in a really nice way inside of the UI. When you're defining your deployments, you get to describe things like apply this operation to the largest enabled server group in a certain region or namespace. This is really powerful when you start to define advanced ways to roll out traffic to your users. You have context-driven rollbacks. When you open up the rollback panel on the server group tab, you get to see exactly which versions are safe to roll back to. Spinnaker has great ways to do artifact promotion across environments. Right now, this only works for like the find image stage style of doing artifact promotion, but this can be expanded to other things as well. But to get all these features, there's just like a couple things you have to accept when you implement it like this. So one, Spinnaker has strict naming and labeling rules. The naming comes from Frigga, which is a library implemented at Netflix during the Asgard time to allow you to derive these resource relationships. All your resource definitions, which would typically be like your Kubernetes manifest files, now instead have to live inside of your pipeline definitions instead of maybe separately in GitHub or in GCS or someplace where you're generating and storing them. And finally, things like services, ingresses, network policies, these you can't really easily create inside of the pipeline, and Kubernetes makes it really easy to deploy full stacks. On the other side of the coin, you have the manifest-based deployments, and these they also enable some really nice things. So one, you get to code review your infrastructure, and that's really powerful. You actually see in Git before you make a change, or in whatever version control you use, what change is going to happen before you make it. You can now start to treat manifests as the artifacts that you're deploying across environments. So you have a definition of a replica set, and you're deploying it to your staging environment, and it has some change in it, and you want to promote that actual change across into production. You don't just want to change the Docker image each time. Last, you always make sure that you're in touch with the Kubernetes spec. If there's a new feature added to a replica set, or there's a new resource type that allows you to use GPUs or something, you out of the box guarantee that it's going to work with Kubernetes. There's one more actually. You get to deploy, like I said before, your entire stack at once. So maybe you have a lot of Kubernetes clusters, and in each one you want to deploy a mostly identical environment. If you have all these manifest files living somewhere, it's very easy to take those and redeploy those in every single cluster. But at the same time, doing this naively is, for reasons I'll get into, not possible with Spinnaker today. So for the rest of the talk, I want to go into what we need to do to make this work. So there's 3 key problems, and we can break this down, and we'll try and convince ourselves that if we solve these, we're going to have a way to actually use these manifest files inside of Kubernetes. So number 1, we don't want to restrict the way you name and label your resources. Right now, Spinnaker makes assumptions about the fact that everything's named following the Frigga naming convention. It also assumes that you've labeled your resources according to the Spinnaker convention to ensure that strategies like red, black, and traffic shifting work. 2, we want to, I'll explain this in more detail later, but if you're given a raw manifest file, it's not exactly always clear which artifacts in there you're trying to promote across environments or which ones from the pipeline context you want to deploy. I'll give some examples in a minute, which will hopefully make this a little more clear. And then finally, very simply, how do we deploy manifests stored outside of Spinnaker? If you have something living in Git and it has a different life cycle than the typical Spinnaker pipelines, how do we reconcile those 2 things and make sure we don't introduce any consistency problems? And luckily, there's actually 2 ways we're going to solve this. So one, if you're familiar with Spinnaker, this is already going to sound painful, but we have to find some way to generify Frigga, which kind of pervades all of Spinnaker's code base. And then 2, and this is largely built on Guard's work from Shivstead, it's the artifact decoration, which promotes a more generic definition of what's an artifact inside of Spinnaker. All right, so one, generifying Frigga. Before we jump in and say this is what we have to do, it's good to ask ourselves what purpose does Frigga actually serve inside of Spinnaker. So if you're familiar with it, it breaks every name down into 3 components. You have an app, a stack, and a detail. But what Spinnaker is really doing with that is it's deriving all these relationships. So in green, you have your infrastructure resources, and those are associated simply by naming to these logical groupings like applications and clusters. And without this relationship, none of Spinnaker's orchestration would work. On top of that, we have labeling constraints that we also want to relax between security groups, which are like network policies, and load balancers, which are services and ingresses, and the server groups. So you might wonder, instead of going through all the work to actually tear out Frigga, why not just impose the labeling within the manifests that users want to deploy? Most obviously, it's actually pretty annoying. It's frustrating to have something you can name however you want to, and then have all sorts of special rules applied on how you can actually group and name these things. But more importantly, for any of the Spinnaker deployment strategies to work, you need to apply maybe like a random suffix or a random string to each replica set or server group you deploy to ensure that when it gets updated, you're not recreating the same resource. And this is what Spinnaker does right now with those sequence numbers, but it's at least something needs to happen. So requiring users to do this with every time they make an update and they want to deploy, that's another bit of frustration and adds potential error. Next, if you just go in and were to say Spinnaker should do some sort of naive renaming of resources, it starts to get very complicated quickly because there's relationships in Kubernetes which depend on name. And if you don't go through the full dependency graph of all things that could depend on one thing or another, you start to break these kinds of relationships, especially auto-scaling. Next, if you say, I don't care about using replica sets, I only want to use deployment objects and stateful sets, it doesn't matter to me if I have to rename these things. You're not always going to be able to infer the cluster relationship, which is needed for things like Spinnaker Canary to actually make them work. And then relationships between things like server groups and load balancers or server groups and security groups. You can't infer these things when they're in the disabled state. And being able to disable things in Spinnaker is very core to a number of the deployment strategies and orchestrations that it does. And finally, any sort of way to import resources into Spinnaker spec would require you to make changes to the way you're running infrastructures deployed right now. And Kubernetes, as far as I know, will be banning those changes soon. So you'd have to actually take down and redeploy your services and ingresses to make it work. To summarize, it's brittle to rename resources. In many cases, if you actually want to import things into Spinnaker and we require these types of constraints, you'll have to deploy things which really can't suffer from downtime. So the simplest thing to do here, without going into the details of how to replace Frigga, is really just to have Spinnaker annotate the resources in the Kubernetes fashion and do that automatically for you. So in this annotations field, in every single Kubernetes resource, you can pretty much record all these relationships, and Spinnaker will be in charge of writing and reading those to the manifests, but you can supply them as well. So this is all done by Spinnaker. Which brings us to our next point, and that's the artifact decoration. And we'll go into how it solves the various problems there in a minute. But first, I'd like to give you a little bit of background. So ideally, we want to generalize the idea of what you can deploy inside of Spinnaker. An artifact can be a lot of things. It can be an image from the various cloud providers. It could be a resource in a cloud provider, like a config map or a secret for Kubernetes. It could be an object in some version of Blob Store, or something in Git. There's really anything that you could imagine having to deploy that lives in some remote environment. There's 3 fields in the artifact definition we're going to focus on. There's a type, a name, and a version. To give you some examples, you could say a Docker image as a type, Docker/image. The name is the actual Docker image name, and the version is the tag that you want to deploy it at. If this were a Git file, you'd have the type be Git file, the name would be the actual file in the Git repo, and then the version would be the commit hash that you want to download it at. And some things, like things in GCS, may not necessarily have versions, and you would just omit the version in that case. So this raises a question, how do we actually supply these to pipelines, and later on, how do we use them? One thing we have to do is we need to supply several at once. If you have these represent the things you want to deploy, and you have a Docker image that you're updating, and you have a Kubernetes manifest that you're updating, it's important that you can say, both of these changed at once, please deploy both of them for me. But there's also cases where maybe only the Docker image is updated, or maybe only a config map changed, you're doing some sort of a config push, you're using feature flags, or maybe only your manifest changed, and that's the only thing that's available to Spinnaker. And using the existing Spinnaker triggers, this is difficult. So we have to rethink how that relationship works. And right now in Spinnaker, one trigger roughly corresponds to one artifact. But we have to break this model down and say instead, for a trigger in Spinnaker, you have one trigger event per pipeline execution. So every time you start a pipeline, it was started by some trigger the way it works right now. But each trigger should be able to supply as many artifacts as it wants. And on top of that, the user has to be able to specify how to handle artifacts that don't arrive in a trigger. So for example, the most obvious way to handle that would be to fail the pipeline. You could also say, use some sort of a string constant or a Spring expression language expression to resolve what the artifact should be. Or finally, and probably most useful, is you should be able to use a prior execution from this pipeline or another, use that artifact in its place. So say, for example, one time you push a change to a manifest and you supply that as your only artifact, and then the Spinnaker pipeline goes and says, well, last time I deployed this Docker image at this digest or tag, and then pull that back into my pipeline context. This allows us to very easily answer this question. How do we deploy manifest stored in Git? It's pretty easy. We say we want to expect some sort of an artifact that resolves to textual information, so something like in Git or GCS or S3. And then we point our deploy stage at it, and we say, this is the manifest that we want to deploy. And that's pretty much it. And now we get to the trickier bit, which is, what if we want to update things inside of that manifest that's been deployed to us or supplied to us? So in a simple example, you might have something, you have a Kubernetes specification, you have a single container listed in there, and in your pipeline context is a single Docker image. In this case, it's pretty obvious what the relationship is there. We can make it a little more complicated. We can say that you have a config map storing some sort of feature flags and an image side by side, and in your pipeline context, you have a Docker image and a config map. And again, it's not as obvious, but it's still pretty straightforward. But what if you have multiple container images, and one's a primary container, one's a sidecar, and you expect to be able to update more than one at a time? In this case, it's really not so obvious just from looking at it like this. So going back to what we had in the artifact handling, we have these extra fields. So if you have, in your pipeline context, an artifact with a certain type and name, and then your manifest, you have the exact same type and name, you can use the version to match these artifacts. So in this case, you say, okay, in my pipeline context, I had my Docker image, gcr.io/my image, and in the specification, I have exactly that right there. What you'd wind up deploying is just version 1.3.0. So let's scale up the complexity a little and start to examine how this works in real workflows. So say you want to deploy a full stack, you have a horizontal pod autoscaler, a replica set, and a config map. And then this replica set itself contains 2 containers. So you draw the dependency graph. I've abbreviated all the names. Roughly looks like this. So you wonder, what do I actually define inside of Spinnaker? You say, all right, so I expect 2 Docker images and a bundle of files from GitHub. And then inside that pipeline, you would say, okay, my deploy stage requires me to deploy the manifests in that bundle of files. And I'm going to annotate how they relate to certain Spinnaker constructs like my account, my cluster, and my app. And that then resolves to those annotations we talked about earlier. So what does Spinnaker do in this case? One, it needs to resolve these manifests out to what it actually is going to deploy. It says, okay, so there's 3 manifests in here. This is exactly what I think should be. And now it figures out what's the dependency between these. So we figure out that same dependency graph from before. And the first thing it does, it says, okay, anything that I need to deploy needs to depend on other things that are already deployed in that environment. So to do that, it goes and says, all right, the config map needs to be deployed, and it needs to be assigned a version. It's important, I think, to think about config maps as things that have versions as well, even though it's not necessarily a first-class construct in Kubernetes. Because if you want to, at some point, roll back to a prior definition of this replica set or deployment object or stateful set, and it depends on a config map that's changed, if you haven't actually updated the version when it changed, you won't be able to safely roll back. So at this point, the replica set's ready to be deployed. All we have to do is determine what the versions are. We look inside the pipeline context. We see we have 2 matching images and the versions for these images. And we deploy that as well, assign it a version. And then finally, we go to the horizontal pod autoscaler, and we do the same there. With that finished, let's talk roughly about what's in the way and what's been done to complete the implementation. So there's these 6 milestones. They're a little more detail-oriented than they need to be. But so the first thing that needs to be finished is we need to deploy and annotate these resources inside the Cloud Driver implementation. Then we need to cache them. And in doing so, start to decouple Frigga from the various subcomponents. And then finally, once we have this, we can start to expand manifests supplied either from Git or from other sources and plug artifacts in. And at this point, it starts to become interesting because you can start to define full workflows end-to-end where you have artifacts coming from various sources. You can have Docker images coming in. You can supply your manifest in your pipeline, and then actually have deployment pipelines defined. And then after that, we hydrate manifests from these sources, and then support deploying multiple manifests at once, doing that dependency resolution, and deploying full stacks inside of single deployment pipelines. The final thing that I didn't touch on here is the JSON implementation. To talk about it briefly, in many cases, you'll have manifests that differ very slightly between various environments. Maybe you have something specific to production in your environment, in the way your ports are configured, or which service they sit behind, or which network policy they require, and then that changes from that to staging. And to be able to define that and define that once, and then say that when I supply these changes for production versus these changes for staging, you should be able to expand and hydrate these manifests between these environments. And the JSON integration should be able to achieve that. Any questions?
So what's kind of the thought with like secret values? Like talked about config maps, would it just be secrets committed to Git or to object store or whatever and have the full secret there?
That's a good question. So for secrets, going back here, so in this case, where you have all your resources stored in Git, you have the luxury of being able to store them securely in a place where people can read them. In the case of a secret, you wouldn't want to supply the artifact as something as a Git file, but instead as a Kubernetes resource. So instead of saying, I have 2 images and Kubernetes manifest, you'd say, I have 2 images, an already deployed secret, which came from a secret store, or already sits in this environment, and then my Kubernetes manifests, and then the dependency resolution goes from there.
How are you dealing with rehydration if one of your image has? How do you tear down and scale up your new image?
The image for like baking an image?
Yeah.
Image baking.
Baking than it is to actually do the deployment.
Sorry, what was that?
The deployment aspect, not really the baking. Sorry.
The deployment aspect of the image, how do you deal with tearing it down and bringing up a new one?
Yeah.
Okay, so if you want to rely on the native Kubernetes constructs that already has a thing that pretty much does this for you, it's called the deployment API. You have this thing which, whenever a change is made to it, it'll actually go ahead and do a rolling deployment of individual pods, rolling out that new image that you specify. Spinnaker also has ways to do this. In this case, you'd say, I have a replica set and I want to do like a red-black deployment, or I want to do a canary deployment or a rolling red-black, in which case Spinnaker would do the orchestration of bringing up the new replica set with the new image and new configuration, and then either tearing down the old one or disabling traffic to it or doing some gated rollout. All of those are possible.
So Lars, assume based on all these changes, it's not going to be backwards compatible, is it? You're not going to go there back to what's already deployed and annotations. So.
Yes, that's a good point. The old client library that we were using has some idiosyncrasies that make it not fully compatible with the Kubernetes spec. So in order to actually accept the manifests as they're supplied versus what we expect right now based on the client library we were using, it's not possible to have those deploy stages be backwards compatible. The nice thing though is if you want to import your pipelines or you import your resources, it's very easy for us to annotate these automatically. So if you want to switch from the original implementation of the Kubernetes provider to the new implementation, you would re-annotate your resources, do probably a little more manual work in your deployment pipelines, but then basically be back to where you were before.
Sorry, I don't know if there's someone else.
Do it first.
So I think one concern is like most of the times when you go to YAML file, we're not really deploying the YAML file, you're deploying a template, a J2 file that's going to, so there's always variables there. So like, you kind of mentioned that, but can you extend a little bit more how you're going to have a YAML file, how to deploy a dynamic YAML file, a template?
Yeah, this is something I didn't spend enough time talking about, the JSON integration.
Yeah.
So JSON came out of well, it's not the language we're sold on, but it's assumed we have some sort of templating language. The goal really is to specify within Spinnaker, here's a template, and then in your deploy stage, instead of pointing at a GitHub resource, you would point to a template resource, and then have well-defined rules for hydrating that template. And in doing so, effectively, you wind up with that same like HPA.yaml or rs.yaml, but inside of there, when it comes time to replace the artifacts, you can either rely on your templating solution to do that by supplying it with details from the pipeline context, or rely on what we've given you here, which is to say that once the type and name match, we plug in the the version of whatever the new artifact is. So to actually get those small changes which aren't relevant to the artifacts, you would specify inside the template, you would say, this is my template, here's how to hydrate it based on the pipeline context. And the pipeline context can have parameters that you define in the typical Spinnaker way, like you say, like my environment is staging, my environment is production. And in there, in that template, actually produce that Kubernetes YAML file.
The design approach, does it preserve our ability to have developers run on Minikube? Or is this annotated manifest something that will only run in a Spinnaker environment?
The annotated manifest can run anywhere. The annotations are like a first-class construct in every Kubernetes resource. So if you want to have Spinnaker annotate, or you want to annotate by hand the resources, whether they're running in Minikube or in any Kubernetes cluster, that shouldn't have any sort of effect.
From what I understand, you're basically turning Spinnaker into a glorified like template rendering engine. But then there's this aspect of Spinnaker that's like operationalizing, like presenting to developers a UI where they can do things like disable a replica set or roll back or whatever. How are you integrating the operational functionality in Spinnaker with this sort of ambivalence or just the fact that you're just shipping templates?
It's a good question. So the whole idea behind actually attaching those annotations is to enable those things like this enable and disable. So for Spinnaker to go in and say, like, I want to roll back this replica set to this version, it needs to know which load balancer it's attached to. And for it to know that, you need to have either some sort of labeling restriction like we have right now, or some sort of annotation already applied. And because we have these annotations in this new iteration, and you do decide to issue like a rollback or a scale down or any of these things, Spinnaker behaves just like it normally would on these on the already deployed manifests and issues the operation there basically. On the point you made about it being like a glorified templating engine, you also have things beyond that where, say, you deploy a replica set and you want to issue like canary analysis on that. For it to do that, you need to know additional information like which cluster it belongs to, potentially which metric sources to grab. All these things are stuff supplied to Spinnaker and extracted from the manifests, which I guess you wouldn't necessarily get in a very naive template-based deployment tool.
How does, so, you know, if you have a deployment in Kubernetes and Kubernetes is somewhat doing the rolling deploys, how does Spinnaker get access to interrupting that? Or, you know, because if you're dealing with it through Spinnaker, how does that all combine together?
If you're relying on the deployment API, you ideally wouldn't be interrupting those. If it becomes something that's interesting and people want to do this, the deployment API supports a pause operation. So we could artificially inject pauses into various stages of the rollout, but so far people seem either happy enough to have a linear rollout with no gating or have a all the way red-black kind of deployment.
As you get into pipelines that have multiple artifacts, and I'm a little bit worried about the preserving the atomicity of actions versus the provider, as there are a lot like HPA, replica set, all of that. Are there challenges that you anticipate as you broaden the set of artifacts and actions that can be taken as part of a single rollout?
Is your concern that someone might deploy too many artifacts and that has some unanticipated side effect?
Like the atomicity of actions, like in terms of, because you actually expect to.
So the expectation is that everything is deployed at once, but in reality, there's a lag between the various resources. Yeah. A nice thing about the Kubernetes API is that if you deploy things out of order or there's a lag between them, things don't necessarily break. You don't have to worry about something that's required existing right at the moment it gets deployed. If you deploy a pod but the config map doesn't exist, it'll first try to come up and say, I can't find the config map, and then try again in a couple seconds and see that whatever it needs is there. Those kinds of atomicity concerns I haven't considered before for that reason, because typically when things come up out of order or they come up with a slight delay, Kubernetes is graceful enough to handle those problems. Does that roughly answer your question, or do you have other concerns?
And if it's working, then
great. You can also ensure this by always uploading the entire context. So if every CI build uploads the Docker container, the manifests and everything, you can have a consistent kind of atomic or you always know that the entire runtime environment is defined in that CI build. So with if you're resolving based on what's running or the previous execution, you can have like, if you do a rollback, you might inherit some settings from the old pipeline execution. But if you upload all the artifacts, then you know that this is the state you will receive after a pipeline execution.
There'll still be, I guess, some parts of the manifest that are outside of Spinnaker, like you talked about secrets or the ingress piece. We're still going to have.
Ingress won't necessarily be outside of Spinnaker, but secrets because Spinnaker doesn't really have a good built-in secret solution, should probably be stored outside of Spinnaker, deployed outside of Spinnaker, and then if required in a version capacity, supplied to a pipeline where you'd say, this is the secret of this version I want to deploy. But if you don't care about the versioning aspect, you can deploy it once, reference it statically, and then never worry about updating it again.
The ingress piece across multiple applications, right? Because it has a virtual host and a URL. All those pieces typically right now seems like would be outside of an application deployment, right?
Maybe I'm missing something. What about the ingress? Like if you can create an ingress with kubectl apply, you should be able to create it in this context as well. Is the concern that maybe the ingress has to exist a long time before the rest of the application does?
Like a separate piece that gets deployed outside the application. Because the application goes to like essentially the load balancer, which is the service binding. But then you have all those other pieces on the left side, all the way to maybe the ELB if you're deploying it that way. Better.
Yeah, that's a good point. And what I would say is that if you prefer to have all that existing before you deploy anything else, you're welcome to deploy it that way. If instead you want to very quickly spin up and tear down stacks where you want to create everything from the ingress down to the pods, then you can define in a pipeline and order the deploy stages in the way that makes sense to ensure that the ingress comes up first, wait for that to be up and ready, and then deploy the rest of your stack if you need to.
It's the bindings that are in there that need to match. That's the concern, right? Since they're not, or potentially if they're out of step. So today, like we have a large manifest that we apply, and it has a lot of things in it. And since we're managing like that, we can make sure they're all consistent. But if we get in a mode where like we have secrets deployed outside or the ingress piece deployed outside, then they can get in a state where they might not match. In terms of
what are these matches you're concerned about?
Like let's say the name doesn't match exactly what it's named in the pipeline, so that so it might be out of step. So
does the ingress depend on the name of the replica sets?
I thought there's the name that's in there that needs to match.
I think there is for the services, but the services you wouldn't deploy in a version capacity. Those you can generally deploy once, and then unless you need to tear it down and spin up a new one, that name remains static. It's really important that the service names do remain static because they're used for service discovery. So if that name changes, then your application changes too. So I think you can safely assume that names that in Kubernetes that need to remain static will need to remain static in this context too. You wouldn't expect to change all your service endpoints or break naming relationships that you can't somehow resolve. But it's a good point, and I'll make sure to put that into the ingress work.
I was wondering what your time frame for getting this completed.
It's a good question. So we have this first step done. Second step largely done minus the UI work. The rest, it's really quite variable simply because the Frigga changes that need to happen are very sweeping. The artifact work needs to largely be done from scratch. And then the JSON work will happen after that. But up until step 5, I would hope a few months, no more.
So on step 4, say deploying manifests from Git, GCS, Blob Store, whatever. What's the is the interface for that going to be fairly? I'm hoping that it's going to be fairly pluggable.
Oh yeah, absolutely. So we can talk more about the artifact work. So that type annotation we had. Yeah, so the idea is basically that we haven't decided where this is going to live, but someplace you basically describe for a certain type, a certain way to fetch these objects. So you fill in this interface that accepts an artifact of a certain type, and you know the name, you know the version, you have stored somewhere in your configuration various credentials, whether that's like an IAM role or like a JSON key file, and then this implementation living maybe in a cloud driver or a shared library would then just take by name and version and type and download that artifact for you. So it should ideally be as pluggable as possible. We don't want to restrict artifact sources. And there's interesting things you can do later with writing artifacts back, like perhaps for the sake of auditability, after the manifests are hydrated, you want to write those back into Git, and then you give Spinnaker Git privileges or the privilege to open PRs against your Git repo, and then have it write those things back or back into GCS or wherever they live.
And kind of follow on question to that. Gina,
Oh, no, go ahead, sorry.
I guess how much discussion crossover has there been with like in relation to Helm? Because Helm kind of attempts to solve some of these problems, obviously in a different way.
No, it's a good question. Helm is best suited, I think, from my experience and going through it and reading about it, is deploying things in like a one-shot fashion. Like you have like a Redis server or something that you want to deploy, but not actively manage in the sense that you're not updating it constantly. In that case, like if you want to deploy that inside of a Spinnaker pipeline, it's really easy to define a script stage that just says Helm apply on those resources, spins up Redis, and then you never look at it again, basically. In Spinnaker, the expectation is that you're actively carrying config changes, you're rolling out manifest changes, you're deploying Docker images. These kinds of things don't work so well in Helm, and Helm's not really built for that use case.
You consider making Spinnaker pipelines themselves artifacts, so you could like provide them in some way, like give developers some way to like ship their pipeline as part of one of these manifests or something. I don't know.
No, that's a very good idea. That's a credit you for that. Thank you.
You're welcome.
Plan to have V1, V2 existing at the same time?
Yes, so the way this looks in Cloud Driver, you can do this right now if you want to. If you have a Kubernetes account running at the default version V1, there's a field in there you can set provider version. If you set that to V2, you'll switch to the new implementation. It means you have new caching of resources, new endpoints for accepting various operations. The idea here is if you have an account or like a context in Kubernetes that you want to try to migrate over, you can create that account twice effectively, once for each version, and then see that as your migration goes along, all of your resources and pipelines effectively double. All right, if there's no more questions, cool. Thank you.